Backup and recovery. Easily the biggest responsibility of every database administrator out there today is ensuring that our data is safe, especially in the event of a failure. We need to be able to get our data back to the state that it was before that failure occurred. And the two four-letter words that you never want to hear from a DBA is data loss, because if that occurs, there'll be many other four-letter words flying around. So in this nugget, we're going to look at disaster recovery. Backups have always been and still are today the number one way to ensure that our data is recoverable in the event of a disaster. Let's jump in. Now, there's a lot of factors that are going to weigh in to your disaster recovery strategy, and planning is a big part of coming up with the right strategy, and also understanding your database, the volume of data, the frequency of data, the kind of data, and even how much data loss, if any, you can endure in the face of a disaster. Once we understand all those variables, then it'll become quite clear as to the kind of backups we should be performing and the frequency at which we should be performing them. And there's a lot of other things that goes into your strategy, like testing it and automating it. But let's take a step back and just get familiar with all the pieces of backup and recovery. The first thing we're going to touch on here is recovery models. Every database has an associated recovery model. There's 3 of them. We'll go over them here. But essentially, a recovery model is going to dictate the kind of backups that we can perform and how much data loss we'll endure when disaster occurs. So the recovery model directly controls how transactions are logged and how much, if any, transaction log maintenance we're going to be performing. Let's talk about that transaction log for a minute. It's a big part of every SQL Server database. So every single operation that hits SQL Server, hits a database, is first put inside of the transaction log. So the log is literally just a big list of all the statements that hit the database. And this serves a couple of purposes. Number one, SQL Server will have a record of everything that hit this database. And so it hits the log first before it actually gets written into the underlying data files. And the reason that we have a transaction log is for a couple of things. For rolling back and for rolling forward. Let's say I have a stored procedure, and it's a big stored procedure, and I have lots of statements inside of there, and I wrap them inside of a transaction. That will treat that as an all or nothing proposition. And by the way, every single statement in operation is a transaction. Even just a single insert statement is a transaction. It's an implicit transaction. It just happens. But when you're dealing with many statements, you will need to explicitly define them inside of a transaction block if you want to treat them all as one unit. Now, back to where I was getting at here. Let's say that SQL Server crashed in the middle of that stored procedure. So we have a partially completed transaction, right? We've got a couple of insert statements that ran, and maybe everything underneath it, a couple of update statements to other tables, didn't run. When SQL Server comes back online after a disaster in the middle of that stored procedure, it now has the ability to look at the transaction log and say, oh, look, this was an incompleted transaction. Let's roll back those statements that occurred. And that means we're going to have a consistent database, right? Because if SQL Server didn't have a transaction log and wasn't able to roll back all of those statements, then we would have inconsistent data and our database would be a mess. So that's one of the big things that a transaction log will do for us. It has the ability to roll back incomplete transactions in the event of hardware or software failure, and it can also roll forward transactions. If a transaction completed before the server went online, but it didn't quite write all of that information to the data files, when it comes back online, it can say, oh, look, this transaction actually completed successfully. I just didn't write it into the data files. So then it can roll forward those successful transactions. So the transaction log is extremely important, and SQL Server heavily relies on it to ensure that our database stays in a consistent state. All data operations hit that transaction log before getting hardened to disk. Now, back to recovery models. Again, a recovery model is going to control how transactions are logged, and it's going to directly affect our backup and restore ops. We have 3 recovery models: simple, full, and bulk log. Let's start with simple here. Simple, as the name implies, is the most basic recovery model. And how this works is the transaction log is still used, but once a transaction is logged and then written to disk, the space in that log is reclaimed, which means there will be no log management. And believe me, when you're dealing with the full recovery model, you're going to have to deal with log management because that log is going to grow and grow and grow until you do something about it. So that's another big part of every DBA's job, is ensuring that their logs don't get too big. So with simple, no log management, great for dev environments, but of course there's a big trade-off here, right? And that is because you really don't have access to the full transaction log. These transactions are getting removed when they're done. It means we're going to lose some of the advanced features. We're not going to be able to do always-on availability groups. We're not going to be able to do transactional replication. We're not going to be able to do database mirroring or log shipping. A lot of the advanced things that have to do with transaction logs, really all around synchronizing databases. But this also means that we're not going to be able to do transaction log backups, which means we're not going to be able to do point-in-time recovery. But these still certainly have their use cases, and that's going to be, again, in dev environments, because nobody wants to manage a transaction log in dev environments, but also good for databases that don't change very often, or you can easily recover all of the data, or your data isn't critical and can easily be recreated. Kind of like our TestDB and our virtual Nugget Lab. We've got scripts that can recreate the entire database, so probably good to leave that one in the simpler recovery model. The full recovery model is what you'll see most often used in production environments, because we're telling SQL Server to keep all of that transaction data in the log. And it's going to keep it in there until we either perform a transaction log backup or a DBA manually truncates that transaction log. But this is going to give us access to all those advanced features around the transaction log, as well as the ability to do transaction log backups, which means we can do point-in-time recovery because we have the transaction logs. So if data corruption occurs or a disaster occurs, we can restore right up to that point just before it occurred. Lastly, here we have the bulk logged recovery model, and this is really just an adjunct to the full recovery model. It's full without logging any bulk operations like your select into and your bulk insert. And generally, you're going to use this in those special use cases where you need to load a bunch of data into a database and you don't want to bloat the transaction log with all of that data. So you'll flip it to the bulk logged, run your loading operations, and then flip it back to the full recovery model. Now let me show you where you can find and change the recovery model in SQL Server Management Studio. So here we are in the Virtual Nugget Lab. Let me bring up Management Studio. If you right-click on any database, head down to Properties, and then head into Options, you will see the recovery model right here. Drop that down, and there are all three of our recovery models. So you can see I have our Music DB set to full, which means we would need to ensure that we manage our log file. And here it is. If you head into Files here, here's our log file right here. If we head over to the right, you can see here is the path, and here to the right is the file name. Always an LDF extension. By default, you'll have an underscore log on the file name as well. So that's your transaction log, and let's take a look at TestDB here, because I set this one, if we head into Options here, to our simple recovery model. So we wouldn't have to do any sort of transaction log management on our TestDB. Let's take a look at our backup types. The three major backup types we have are full, differential, and transaction log. A full backup will back up all the data in the database. So if you have a big database, that could take a while. A differential backup will only back up the changes since the last full backup. So a lot of times what you'll see is you'll do one full backup maybe once a day, depending on the size of your database. If it's extremely large, maybe you do it once a week or once a month. And then you'll do differential backups, right? Maybe you do this every 6 hours or every 12 hours, again, depending on the size of your database. And how this works, though, is when you do a restore, because the differential contains all the changes since the last full backup, right? So it looks something like this. These differentials will continue to get bigger and bigger. You only need to restore the full and your last differential backup. So every time you do a full backup, it resets the chain. This is also known as your backup chain, by the way. Finally, we have transaction log backups, which are going to back up all the log records since the last log backup. Now, let me give you an idea of what a typical backup strategy would look like. Let's say that we've got a production database that's fairly busy. Maybe it's 100 gigabytes in size. Here's what a pretty standard backup strategy would look like. We would do full backups once a day, right? Once a day, maybe at midnight. Then we would do differentials every, say, 6 hours, and we would do transaction log backups, we'll say, every 30 minutes. And depending again on the frequency of data and what our recovery requirements are, that could even be down to the 5-minute range. But here's what a typical day would look like: F, D, T, 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 lots of T's in there, then another D, then lots of T's in there, then another D, right? So there's what your day would look like. Now, if disaster occurred right about here, what would we have to do? We would recover the full, the differential, and then these two transaction log backups, and maybe even to a specific point within this log backup to get us to that exact moment before disaster occurred. This also highlights why it's very important to keep your backups safe. Because if we lose our differential here, we're only going to be able to recover from our latest full backup. If we lose our transaction log backup, we're going to only be able to recover from our latest transaction log backup because we created this chain. So we'll only be able to recover up to the latest file that we have. Here are some more examples illustrating the difference between the simple and full recovery model. Remember, with the simple recovery model, we can only do full and differential backups. So that means if we take backups throughout the day here, like we're doing right here, and disaster strikes before we take our 6th backup, we're only going to be able to restore up to our 5th backup, as you can see right here. So we would suffer some data loss. Anything after that 5th backup would be gone. And you can see with our full recovery model, there's no data loss at all, because we do a full backup and then a bunch of log backups throughout the day. And if disaster occurs after our second log backup, but before our third log backup, when SQL Server comes back online or our database comes back online, we can perform a tail log backup, which just basically means give us all the data that's currently in the transaction log. And we can then use that as the last backup to recover to the exact point in time that we need it to. Let's jump into the Virtual Nugget Lab and take a look at the backup and restore process. All right, so we're back in the Virtual Nugget Lab. We're going to be working the Project 22 backup and recovery. I already ran setup.sql. Make sure you do that. That'll just load up TestDB with our certification database that we designed a few nuggets back. And now, let's say we want to back this database up. But I want to show you transaction log backup. So what are we going to need to do? Yeah, double check the recovery model. We know TestDB is under simple. So let's head into properties here, into options. And let's just switch this from simple to full. There we go. Now we're into the full recovery model. Now another thing I want to do before I actually show you how to do this in SQL, which is the way that we will do it, is just show you the GUI. Very easy little GUI here to do backups. We'll right click on any database, head into tasks, and head up there to backup. This is the dialog you'll be utilizing for backup. Choose your database that you want to back up. Choose your backup type. Notice here that it also shows us the recovery model, because if it was simple, transaction log would disappear from this list. You'd only have full and differential as your options. Your backup component is going to be the full database. You can also do specific files and file groups. And then your destination, if you want to back it up to a disk, which is the default, and which is what we'll do, it'll create a file in the default location, which is the backup directory inside of our instances directory. So .back will be the file extension. You also have some media options here, which is nice, because when you do restores, it will actually kind of organize all your backups for you under a nice label. And then you've also got some options here as well, like compression and encryption, and you can set expirations on the backup and all that fun stuff. But we're going to hit cancel here and do this through the UI or through SQL, which is very simple, right? Backup, database, name of the database, to disk, and specify the disk. Now, I actually created a new drive just for this here, our B drive, which will be in the Virtual Nugget Lab for you. And I created a directory called SQL Server Backups, which is empty. So let's run this right now. It's going to back up TestDB to disk. Hey, look at that. That was quick because it's a pretty small database. But if we head in here, there's our backup. TestDB _ full .back. Cool. So now let's say the day is going on. Users are adding data. And let's go ahead and add some data. We'll add a couple of records in here. Boom. So we've got some data in there. Now it's time to do a differential backup. So same thing here. We are going to back up our database to disk. This time we're going to give it the name _diff.back, and we're going to say with differential. What does that mean? That means it's only going to back up the changes since the last full backup, which will just contain these two records. So let's go ahead and execute that. There it is. Now if we head in here, we can actually see, look how small our backup is compared, our differential backup is compared to our full backup. So that only contains those changes, which are those two records. All right, let's do it again. Let's add some more data. Switch back to TestDB, add a couple of more records in here, and now let's say we're going to do a transaction log backup. Now instead of doing a backup database, we're going to do a backup log, right? Specify the name of the database, to disk, specify our file path. We're going to do this one, give this one the name _log.back, and this will back up all of the data living inside of the transaction log. We'll hit execute, and there it is. Now if we check this out, there is our transaction log. Cool. So we've got all of our data across those three backups ready to go. And now we can do a restore. And since we did a log restore, let's say disaster occurred after our first record, before our second record, we could back up to that exact moment in time. Now, before we do the restore, let's do something interesting here. Let's add another record in here. Let's go into our certification table, and let's say somebody added a bunch of invalid or bad data. We'll call this bad. And then let's put this for vendor ID 1. This is our ID 13. Cool. So now we've got this bad record in there. We don't want it in there. And it shouldn't be in there as long as we don't do a tail log backup before we do our restore. Remember, a tail log will grab everything after the last log, pretty much anything that's currently living in the transaction log. We already did all of our backups. So just by doing this restore, that bad data should be out of there. But if we want to do a restore, let me show you the UI first here. We just right click on the database, head into tasks, restore, let's do database, and here is what your dialog looks like. So the first thing you're going to do is choose the source. And this is going to directly affect our backup sets down here. Now, it kept a nice history of all the backups that we performed in this database. You can see we've got a full, a differential, and a transaction. And if you want to apply any of these or not apply them, just check or uncheck them. And you can even see some good information around their start and finish date, their sizes, who did it, so on and so forth. But look at this little button over here. This is really cool. Timeline. Yeah, we can restore, because we have log backups, to an exact date and time. We can go down to the hour level and we can start moving this around. And notice if we go after this green line, a tail log backup will be performed. So otherwise, if we put a shit over here somewhere, then yeah, it's going to we don't need to do a tail log backup. But this is great, isn't it? Because we can restore to an exact time. So if we know the server went down and bad things happened at the exact moment, which we will from our SQL Server logs, then we can go up to that point or just before that point, choose this, and it will restore all the data up to that exact point. Very, very cool stuff. Now, we can also restore this to another database. Maybe we just want to take a look at what this data will look like before we actually overwrite our production database. We can restore it to another database. We'll call it TestDB2, which is exactly what we'll do here. So we can also go into the files, take a look at the files, and we can relocate the new database to a different place. And we've also got options here. Now, the last file that you restore, you'll want to do a restore with recovery. If you're recovering a big backup chain, you'll want to do it with no recovery, meaning you want to leave that database in an inaccessible state until you're completely done with your restore process. Also notice we have our tail log backup options down here. And if you're going to overwrite an existing database, then you want to put a checkbox there to do a with replace. Now let me show you all of this the SQL way. Let's open up our restore.sql script. Here's what it looks like. So we're going to restore our database testDB. We're going to do with no recovery because we have more restores to do. And we're also going to put a replace on here because we are going to overwrite our testDB database. There we go. So full backup with no recovery replace, differential with no recovery, and then a restore with recovery. So that'll get our backup, our last backup. Once it's restored, our database will be in a usable state. So let's just close any existing connections we have to this database. There we go. And let's go ahead and hit execute. There it is. So now let's just refresh this. Head back into TestDB, head into tables, open up our certification table, and we should not see that bad record. Cool. In this CBT Nugget, we learned all about backup and recovery. We got familiar with SQL Server's recovery models. We got familiar with the 3 major backup types. And we saw the process for performing backup and restore operations. I hope this has been informative for you, and I'd like to thank you for viewing.